What the? Okay. Elon Musk says today's global chip supply can meet only a fraction of what Tesla and SpaceX expect to need. His answer is a planned factory of unprecedented scale, built for chips that run in robots, vehicles, data centers, and space. But even this bid for independence still depends on machines supplied by one company in the Netherlands. Dispatch. On March the 21st, 2026, in Austin, Texas, Elon Musk unveiled what he called the most epic chip-building effort in history, a joint project between Tesla and SpaceX. The official site reads, "Terafab will close the gap between today's chip production and the future's demand." And the line that frames the whole story, quote, "We either build the Terafab or we don't have the chips, and we need the chips, so we build the Terafab." And this is not rumor. In August, SpaceX published its own statement, and its words establish the company's thesis. It describes a vertically integrated factory with more than 100 million square feet. Bringing these activities together, SpaceX says should enable, quote, "fast, recursive improvements." It names Optimus robots and self-driving cybercabs as edge inference uses, plus high-power chips for space-based data centers. Faster feedback and control of supply are the proposed advantages. Whether they work at high volume remains unproven. So where and how much? Terafab will be built in Grimes County, Texas, about a 2-hour drive from Tesla's Giga Texas. The initial investment is about $16.8 billion from SpaceX and Tesla, with later expansion phases bringing the total toward $119 billion. It will employ at least 3,000 people, and it sits on the site of a retired coal plant next to the Gibbons Creek Reservoir. And then the internet tried to picture it and mostly failed. 100 million square feet, roughly 10 times Giga Texas, 15 pentagons, 30 Burj Khalifas stacked up. One account laid it on a map beside an aircraft carrier in the state of Texas. Another stood it upright, nearly 2 miles tall. As one poster wrote, "The scale is almost impossible to imagine." Elon's own words, "It will be the largest and most valuable building on Earth, by far." And here is the chief executive himself in his own words. "Terafab, Texas," he wrote, "will be the largest and most valuable building on Earth, by far. And it will be, quote, stunningly beautiful. Not the largest factory, the largest building of any kind on Earth." Now the numbers. More than 100 million square feet. SpaceX describes an annual hardware output target exceeding 1 terawatt of compute capacity. That is not directly comparable with national electricity consumption, and the company has not published the assumptions behind the measure. $16.8 billion is planned for the initial phase, with later expansion potentially taking the investment much higher. SpaceX says the site would employ at least 3,000 people. To understand why Terafab matters, look at how advanced systems are made now. Logic and memory are normally fabricated on separate process lines, often by different suppliers, and brought together during advanced packaging. Multiple companies and sites add coordination and logistics, but shipping is not the only delay. Design verification, mask creation, wafer processing, packaging, qualification, and yield analysis dominate the cycle. Terafab cannot remove those physical limits. Its wager is that co-location can shorten the feedback between them. Here is the proposed advantage. Terafab aims to place fabrication, packaging, and testing close enough to tighten the loop between making a device, measuring it, revising the design or process, and trying again. SpaceX calls this, quote, "fast, recursive improvements." The idea fits Elon's development philosophy, but semiconductor iteration still depends on long wafer cycles, process qualification, equipment matching, reliability, and yield learning. Co-location may shorten feedback. Whether that becomes a durable advantage at high volume is the central engineering question. Inside that loop sit the tools, and one supplier is especially important. EUV lithography, extreme ultraviolet, pattern-selected critical layers in leading-edge logic processes. It does not print every layer, and 2-nanometer class manufacturing does not automatically require the newest high-NA machines. Conventional EUV supports current leading-edge production. High-NA is intended for selected layers in later generations. Both come from the same Dutch supplier. And here is the Dutch connection. ASML, headquartered in Veldhoven, is the sole commercial supplier of EUV lithography systems. It began in 1984 as a joint venture between ASM International and Philips. TSMC, Intel, and Samsung all rely on its tools and service network for critical layers of leading-edge logic. Terafab would share that dependence. Elon can build an enormous factory in Texas, but its leading-edge ambitions still rely on Dutch lithography expertise. That creates a strategic concentration risk, not a unique Terafab flaw. The project would depend on ASML's EUV supply, installation, parts, and service network, just as other leading-edge manufacturers do. Export licensing matters globally, but the available evidence does not show that the Texas project has been denied access. The Dutch role is therefore both less dramatic and more important. ASML is not a weapon pointed at Terafab. It is indispensable infrastructure the whole leading-edge industry shares. Now meet the incumbent. TSMC, the Taiwan Semiconductor Manufacturing Company. Taiwanese, not Dutch. Recent estimates give it roughly 2/3 to 70% of global foundry revenue. That is revenue share, not chip volume, and dominance is not the same as a monopoly. Terafab is also not automatically a direct merchant foundry rival. Its immediate purpose is to reduce Tesla and SpaceX's dependence on outside capacity and control their own product roadmap. Intel's participation improves the project's credibility, but the details matter. Intel is expected to contribute manufacturing expertise. Musk also referenced Intel's 14A process generation and said it may be mature by the time Terafab scales. 14A is a process name, not a literal 1.4 nanometer physical dimension, and the available sources do not define a technology transfer or licensing arrangement. Intel involvement makes Terafab more plausible. It does not prove that Intel 14A is already being brought in-house. The planned chips reveal two complementary strategies. SpaceX says AI5 supports full self-driving and Optimus, while AI6 is aimed at the next Optimus generation. Those are on-device inference workloads. D3 is presented for space, including high-power orbital compute. Terafab is therefore not simply edge instead of cloud. It targets both distributed intelligence in vehicles and robots and centralized compute infrastructure beyond Earth. Terafab's site presents 1 billion Optimus robots as a long-term ambition, not a forecast. Each robot would need substantial on-device inference, memory, and power efficiency. Musk has described memory as a constraint, but the precise growth rates repeated by commentators are not independently documented in the material we have. The defensible point is simpler. If Tesla ever approaches this scale, relying only on today's external chip supply would become a strategic risk. Elon ties the project to orbital compute. Quote, "The goal is 1 trillion watts of compute per year. Most must necessarily go to space as US electricity is only 0.5 terawatts." End quote. That is his argument, not an engineering equivalence. The 1 terawatt figure describes an annual hardware output target whose assumptions are unpublished. 0.5 terawatts describes average electrical load. The comparison signals ambition, but it does not prove that terrestrial grids make orbital compute inevitable. The official site argues that space is the scalable future for AI. Some orbital architectures could offer high solar availability and avoid terrestrial land and grid constraints. Some orbital architectures could offer free cooling. Vacuum removes convection, so heat must travel through the spacecraft to large radiators and leave as thermal radiation. Orbits may also include eclipses, while launch mass, maintenance, and replacement remain expensive. Orbital compute is a serious engineering proposal, not an automatic escape from Earth's constraints. It replaces one set of problems with another. So, can the group execute? The strongest argument is its industrial record. Tesla has built large vehicle and energy systems. SpaceX pioneered routine reuse of orbital-class boosters and operates at extraordinary launch cadence. xAI assembled a very large training cluster quickly. That record improves credibility, But rockets, vehicles, and data centers are not semiconductor process integration. Past execution supports the case it does not predict leading-edge yield. But be honest about the bear case, or the analysis is worthless. Elon has never run a fab. Leading-edge yield is learned over decades, not bought. Up to $119 billion is an astonishing bet even by his standards. The Dutch dependency is real. Rural opposition in Texas is real. The day after the announcement, one trade press headline read, quote, "Reeks of desperation." Even TSMC, Intel, and Samsung, with 40 years of experience, still get it wrong. A fab is the hardest manufacturing problem on Earth. So here is the balanced conclusion. Terafab is technically plausible, but highly uncertain. A smaller prototype is a rational way to learn before scaling, and Intel's participation adds manufacturing expertise. Tesla and SpaceX also provide captive demand. Tesla, but a prototype does not de-risk high-volume yield, process transfer, contamination control, reliability, utilities, or the leap to 100 million square feet. SpaceX's recursive improvement thesis is credible enough to test. It is not yet a proven moat, and there is no defensible probability for success. Step back, and the real stakes come into focus. Terafab is about control of critical compute supply. It targets on-device inference in vehicles and robots, while also targeting high-power orbital data center chips. Those workloads complement cloud infrastructure rather than replace it. The project also binds Tesla and SpaceX more tightly around one manufacturing dependency. That supports speculation about deeper integration, but it is not evidence that a merger is decided. So that is Terafab, a bold attempt to combine supply assurance, faster engineering feedback, edge inference, and orbital compute in one industrial program. The Dutch supply an indispensable lithography layer. TSMC remains the dominant external foundry, and Texas is where Tesla and SpaceX will test whether vertical integration can overcome semiconductor physics and manufacturing economics. Dispatch. If you want the next AI security story before it becomes a hearing, subscribe to AI Security Dispatch. We follow the chips. See you in the next briefing.